We officially we gave until 12:05, so one more minute would be perfect.
Awesome. Well, maybe I will do before getting into the session, I will do my room host responsibilities right now. So my name is Annie Burgess, and I'm the lab director here at ESIP. I'm the co-chair of the session, but also am officially the room host for this session. So we'll be the one that's going to kind of give you the where the fire exits are speech. So just a few reminders that the session is being live streamed and recorded. ESIP does have a code of conduct. If you haven't had a chance to see that, I'd recommend checking out the link in the notes page. That while folks aren't talking, we'd love if you could be on mute. And on the flip side, when we are all chatting, we always like to see faces. So if you are comfortable with having your camera on while we're having discussions, we'd love to see you. If you are not comfortable, that is not an issue. Please feel free to keep your cameras off. And I think that was my last room session host announcement. Ben, since you're on and you're the lab fellow, do you want to just also give a quick hi to the folks in the room?
Sure. Yeah, so I'm the ESIP lab fellow. I have been for the last year and a half or so. You may have seen some fun Python things from me last year. And this year I've been working with Annie on kind of collating some of the ESIP lab projects, as well as working on the biodata standards workshop, which you may or may not have been part of, but it happened before ESIP started last week. You'll probably hear from me later this year on a follow-up to our sort of trying to understand where projects are at and where they're going in the future, what kinds of other funding opportunities they may have jump-started for you. And I'm a PhD candidate at Oregon State University, and I work on cryosphere sciences and remote sensing mostly.
Thanks, Ben. It's great to have you here. And Leslie, before I get going, do you want to introduce yourself as well?
Yes, hello, I'm Leslie Shee. I'm at the USGS.
I'm at the USGS. I'm at the USGS.
I think you did the correct person. I'm sorry. I think you know where I'm from now. So I am the coordinator of the Community for Data Integration. And I want to turn it back to Annie to start the session.
All right, great. Well, thanks so much, everyone, for being here on this Wednesday afternoon. It's awesome to see that we have 31 folks in the room today from a really wide variety across the country. So it looks like Fairbanks is our westernmost point, and who can name the easternmost point? Maybe Susan in Maryland? I'd say so. All right. So nice time zone span. So our session today, we're called Building Technical Know-How Through Innovation, Seed Funding, and Community. And today we really have three goals. We'd like to work on building community around developing earth science technologies. You will learn about both mine and Leslie's programs, which we see as two innovation seed funding opportunities. And really most importantly, or not maybe most importantly, but something we are excited about is sharing our paths to gaining technical expertise. So by the end of this session, you should have met a few new people, which, as it so happens, is really important when building a community of technically inclined peers. And in addition, a goal of both mine and Leslie's is to highlight the knowledge that we have acquired through the process of funding many projects really over the last 5 years. So just setting a couple additional expectations for the session, we will be utilizing breakouts, and we will be having what we hope is a conversational session. So we know life is happening and everyone is at home, and a lot of understanding around that. So and life and work are happening still. So I want to give everyone a 20-second break to arrange screens if you need to. So you could always see Leslie and I as we're talking, and you could have the Google Doc open. So I'd arrange some screen splitting if you need time to do that. And if you have another space where you're keeping a tab on life as it works, life as it happens, you could arrange that as well. So I'm just going to be quiet for a couple seconds and get everyone so their command center is dialed in for the rest of the session. Okay, people are seeming pretty busy at work, Leslie. So,
Annie, I'm
yes,
sorry.
yeah, Rick.
Yeah, to get the Google Doc standalone, do you suggest just using the Kiko chat window?
You bet, you can use the Kiko chat window, but I'm also going to paste the Google Doc link as a standalone in the chat right now. So sometimes it's a little easier to see it when it's not in Kiko chat, since Kiko chat takes up some space. So if you look in the chat to the Zoom, you can see it. You could see it there.
Thank you.
You bet. Okay, Leslie, I'm going to hand it over to you.
Thanks, Annie. Okay, I'm assuming I'm showing the correct slides here, but we're going to move into a conversation. And as Annie said, we're really happy that you've joined us. We have a mix of awardees from the current ESIP lab and CDI proposals processes, and members of the broader ESIP community, which is great. And because one of our main goals is to build that community, we're going to have you talk to some people now just for a little bit. And I know this is one of the harder aspects of the virtual meeting. It definitely is for me too, but I'm glad that I already got to meet some new people, even though we're in a virtual venue this time. So soon we are going to break into groups and get warmed up by sharing some information and aspirations. And as mentioned in yesterday's plenary, don't worry if, people have different circumstances, and if you have to opt out, maybe your mic's not working or you can't speak at this time, people will understand. One way to show that is by renaming your name in the participant list. If you hover over it, you can put an X somewhere near your name, and then people will kind of just know like, oh, this person is not able to talk right now. Okay, but what are we going to talk about? So for the first conversation, you're going to get put into groups of, I think it makes sense for about four people. And we're going to share our name, organization, and then either a life or work hack that makes your life easier, or a tool or app that you really like. So don't get nervous trying to think of something right now, okay? If you're paralyzed, maybe just look at your browser or your menu bar, what extensions and things are up there. Just what is something that makes your life easier? Let's share that with each other. It doesn't have to be a perfect answer. So Annie, what would yours be?
My mind was blown the day that I figured out in Google Calendar, after pointing and clicking for years, that if I was in the month view, if I just pushed D on my keyboard, it would automatically switch to the day view. Or if I push W, it would automatically switch to the week view. And I do that 100 times a day as I'm trying to figure things out. And so that was work and life altering for me when I figured that out. Leslie, what's a good one for you?
Well, I looked at my extension little logos and icons, and I have one called Unpaywall. It's an extension that shows you if there's an open access copy of a journal article. When you encounter a paywall, it will like somehow look up the DOI and let you know, oh, there's a legal open version somewhere. So I love that little extension there. Okay, so we're going to break out. Remember the rule of 1/n. So like say you're probably gonna have four people, just kind of mind the time a little bit. I know you get carried away, that's great. So Annie, if you could please break us into groups of 4. We'll have the following conversation for 5 minutes. You will see a countdown window when you have a minute left. You can keep talking for that minute, and then you're gonna be brought into this room, back into the main room. And you'll see in the Google Doc, if you you guys have a great conversation, you can share your bullets of some things for the rest of the people to hear. Okay, so Annie, are we about ready?
You bet. I'm going to open all rooms now, and I'll see everyone back here in 5 minutes. Have a great conversation. Let's see, Richie, did you get assigned to one? Oh, I don't hear you. You're muted.
No, I'm not.
Oh, it says, let's see.
Oh, wait, I've invited.
There you go. Let's see. Hi, let's see. We got Flufford. Hey, Flufford, were you in one of the breakouts or did you join a little late?
Can you hear me right now?
Yep, I can hear you.
I'm supposed to join the 2020 ESIPs.
This is
the
it.
plenary. Yeah. All right. Yeah,
You're in the
Yeah.
you're in the right place. Everyone's just in a breakout room right now, so folks will be coming back really shortly. So
All right. Yeah.
yeah, everyone
Sweet.
should be streaming back in right now. There they
Oh.
all are.
All right. I was a little bit lost here.
Yeah.
Yep.
Oh, and look at all the people with their cameras on. That's so much more pleasant. Okay. Okay.
I have to go back to sharing my screen.
So remember, as Leslie and I are kind of getting our technical swaps, make sure to, if you heard something in that breakout that was particularly interesting, to add it to the Google Doc so your peers on the call can get some additional life or work hacks.
Annie, we are.
Did you want us to make a?
Oh, go ahead, please.
Did you want us to make a list of the tools that we talked about, or just?
Yeah, Daniel, you could add them to the. There is a section of the Google Doc called "List of Hacks or Tools to Share."
Got it. Thanks.
So you could add them right there.
Oh, I like that standing desk one. I need one.
Can you say
Okay.
where the Google Doc is? I don't.
Sure,
where to go.
Tamara. It's in Kiko Chat, but we're also putting the link. The link to the Google Doc is in the Zoom chat right now, so you could
Okay.
find it there.
Okay, thank you.
You bet.
So Annie, does it look like everyone's back into the main room?
I pulled them back beyond their will, so everyone is definitely back in the main room because we didn't give them a choice. So
Okay.
we can we can move right to our next conversation topic that'll work similarly. So again, remember that in our innovation session, Leslie and I are really interested in knowledge sharing and gaining knowledge. So if you're catching a theme of knowledge sharing, it's probably not overly subtle, but that's what some of these breakouts are also around. So our second conversation topic is, if time was not an issue, what technical, I'm going to say life or technical skill would you learn? So Leslie, I will ask you, what would your skill be?
Yeah, I use the phrase APIs all the time, but I wouldn't say that I know how to use, write, or understand them. So I would love to learn that technical skill. And then just for fun, if you wanted to add a non-technical skill, I really feel like I should be able to shoot 3-pointers better. I'm like very, very horrible at them, like less than 0%. So that's time weren't an issue. I'd spend some time on that. How about you, Annie?
So first, a fun fact, Leslie has a Zoom background, but if she didn't, she would actually have basketball art on her wall. So I love that she brought up the 3-point background because we're missing her basketball art behind her. So I was super jealous of this API one that Leslie came up with because it was so good, because I fully agree. If time was not an issue, I would also be on the API understanding and writing train. But I also have always wanted to be better at like electronics and being able to wire things, like you're riding on a snow machine across the Greenland ice sheet and your battery conks out. I'm able to draw power from this GPS into the snow machine and be able to do that with wiring. I have no idea how or understand the skills needed to do that, but I think it would be really cool. Non-life related, I would learn how to play the fiddle. Those are my two. So let's do this again. You've heard mine and Leslie's, and remember, same deal. So after 4 minutes, you'll get the 1-minute warning, and then we will all come back. So I'm going to open, actually first, let me shuffle the rooms. Recreate all rooms. So now you'll be with some new folks, and I will open them and see everyone in about 5 minutes. So timer here. Okay.
That was fun. Our group is back. Kind of
Welcome.
the countdown.
Okay, welcome back, everyone. So again, if you heard something cool, if you're inspired by one of your peers to learn something new, please go ahead and add it to the Google Doc. There's a lot of really great stuff coming in.
All right, Annie, did I get the correct slide showing? Or on to the next slide, I guess.
I think it's time for the next slide, you bet.
Okay.
And I think it's time for you to take it over, Leslie.
Oh, wow. All right, well, welcome back to the main room. That was really fun. Thanks for chatting. So in the next section, we're going to give short overviews of our 2 innovation seed funding projects that Annie and I run, the Community for Data Integration Requests for Proposals and ESIP Lab. If you have any questions, please do type them into the Zoom chat or bring them up, because we want to tell you about these opportunities and give you a way to participate in the future if you'd like to. Okay, so at the Community for Data Integration, or CDI, we have 2 main goals. The first is to grow our expertise and the knowledge base that earth scientists have in working with their data, and also to help us all to communicate across these boundaries that often just somehow seem to be built between us, whether it's your location or your discipline. Sometimes it's very hard to communicate with people who might have information that could help you. And our proposals process, annual proposals process, addresses both of those issues by providing funding up to $50,000 for collaborative work on data challenges. So we provide a forum for communication about the entire process. We look for projects that have broad applicability in their outcomes or their lessons learned. So if you're testing out a new technology and how it could be reused by a lot of people, or if you create an ability to meet a common data management or data sharing need, those are the types of things that we're looking for. Okay, and it is a multi-phase process. And usually we describe it in 2 phases, but we have 3 here today. So the first phase is community ideas and input. So principal investigators will submit short statements of interest, just like 1 page of narrative of what is your idea? How is it going to help us? How can other people use it beyond your group? Then anyone in our community, which has about over 1,000 members now, and it's USGS and external to USGS, government, academia, nonprofit, anyone's allowed to look at those, comment, ask questions, say, oh, I know someone who's doing that, something like that. Have you seen their work? Or I'm really interested in telling you about my similar issue, and maybe you could also cover my issue at the same time. And after that commenting and questioning, then there is community voting to determine a subset of those statements that go on to the next phase. Now in phase 2, PIs submit then a full-length proposal, about 7 pages, and it's done by a formal review panel like usual when evaluating proposals. And we also have our CDI executive sponsors, who are USGS leadership, who make the decisions taking into account USGS priorities. So phase 2 is important because you have the bottom up and the top down kind of meet in the middle. You have grassroots ideas, but they're being aligned somewhat to what USGS priorities are. And then finally, in phase 3, we really try to emphasize the sharing back with the community. So people propose deliverables, which can include tools, best practices, lessons learned. Oftentimes something weird happens and your deliverable is like a lesson learned about what works and what doesn't. Those are communicated back in final presentations to the CDI monthly call. If you want to learn more about our proposals process, which usually happens in the fall, is when we make that call for the first statements of interest. I see Dan has already put the link in there. Thank you so much, Dan. I'll just put it again for emphasis. That is one place to get started. So Annie, can you tell us a bit about ESIP Lab?
Absolutely.
I'm going to move on. I forgot this. I forgot this last slide, which is just some examples if you wanted to know what are these projects. So it covers the whole range of the different types of science that USGS covers. Okay, those links are for you in the slides. So Annie.
Great, thank you, Leslie. So the ESIP lab, it's you'll hear it. Leslie gave a great overview of CDI, and we have a lot of really similar goals. So hopefully you'll see some commonalities between these two programs. So the ESIP lab provides small grants that encourage skill development and community building with the goal of ultimately reducing the time to science. And what we want to do is really create frameworks for learning new technical skills that will serve people throughout their careers. So what you could see on this slide is a very simple scenario where on the left, where we see this as is and time to learn, that we are doing research with our skill set as is, but we keep chugging along on the problem and with the assumption that our productivity will continue to increase. We just have this project, we're working along, so we'll eventually get more done. In other words, we don't want to stop doing our research to learn something new, or we feel like we can't stop our research to learn something new because of any number of issues. I bet if we did a raise of hands to say you think of a research project and you think, well, I could keep with the skill set that I have because of fill in the blank. And so my fill in the blanks from when I was a research scientist would have been near-term deadlines. I don't want to stop and learn a new skill because I have to finish it in 2 weeks. And if I use the skills that I have, then I can get it done. So that leads to a perception of productivity loss, that I won't be as productive if I learn this new skill, because if I kept with my current skill set, I will be more productive. And then maybe a questionable return on investment. What will I gain by stopping and learning this new skill, because it's really an unknown? And I'd invite people to put into the chat if they can think, why haven't I stopped during my research career to learn something that I really maybe wish I would have just done and taken the time? Maybe share some of those with your peers in chat and make us all feel a little bit more normal for just kind of plugging along. So as you can see in the very simplified version of this in the far right figure is that inability, or us not wanting to learn new skills because we have a perception that our productivity will go down over the long term, really inhibits our productivity. That by stopping and learning new skills that will increase our productivity as a scientist, that translates through the rest of our career to actually increase productivity. But Leslie, if you can go to the next slide. So I see that as the kind of the productivity trap. And so within the ESIP lab, our real goal is to change that triangle of the productivity trap into more of a prototyping framework. So if I told you to stop your research and to learn a new skill without any support, then it seems really daunting. But what if we took that same triangle and we pivot it and we said, create some objectives over that time, technical objectives and learning objectives, and we provided funding. And that's really what we're doing through the lab, that from the very beginning, we say, create a project over a 6-month period, and it's okay if you don't know how to do it. We want you to have a learning objective. And because you've thought about a proposal and created a framework, now you have learning objectives to work towards and a small amount of funding, even if it's just a carrot. And so, Leslie, if you can go to the next slide. We try to do this similar to how Leslie walked you through a proposal process. We put our proposals out, call for proposals twice a year with a maximum budget of $10,000 at a time, plus additional, if you need cloud computing credits, we provide those as well. So that can be outside of your $10,000 budget. So we release a request for proposals. And people can apply that are, one member of your team must belong to an ESIP member organization. So you could have 5 co-Is on your team. And if you have one of them that is part of an ESIP or ESIP partner organization, then you're eligible to apply. You also must be eligible to work in the United States. Similar to what Leslie said of looking at USGS priorities, we consult our sponsors, being NASA, NOAA, and the USGS, and ask what their priorities are in this area. What are the things that they would find valuable to have the science community working on? So I consult our funders to see what would be priority areas and include those in the RFP. Then PI submit a full-length proposal, and a full-length proposal for us is no more than 4 pages. So it's a short proposal. The proposal goes out to peer reviewer list. So both people that the reviewers have or the PIs have suggested and other folks that are in that domain area. And then ultimately I use those suggestions to decide what projects end up getting funded. Again, project execution is over 6 months. Similar to Leslie, deliverables can be lessons learned, software, hardware, or hopefully educate, just additional skills. If you are interested in hearing more, you could go to esipfed.org/lab. Even though our current request for proposals is closed, if you're interested in seeing what a request for proposals from us looks like, I'm going to type it in the chat now. RFP, and the next one of these will open this fall. So if you have any additional questions, you can get in touch with me later. So with that, my next slide shows some of our example projects that we have funded. You'd be able to navigate to this from the lab page, but again, just a few examples so you can see what we're doing. All right. Leslie, do you want to go to the next slide? All right, so, oh, sorry, I kind of like, I should mean to go to the slide. So we've both been running these programs for a number of years, you for 5 years and me for 3 and change. I'm wondering what your biggest lesson learned has been after shepherding all of these CDI projects.
Right, so my take-home message for all of you out there is to use the community. This includes the CDI, or if you participate in ESIP too, use ESIP. You have this great group of enthusiastic people, and at least the CDI process and the ESIP process, I feel it's a little bit unique. You're not going to get further if you kind of hold your cards close to your chest and do your own little thing in your group, but you're going to get so much further if you make that initial investment in getting to know the other community members, because they have so many suggestions of connections, technical ways to solve things. You just have to ask and let people know that you're searching for this information. So in phase 1 of the CDI RFP, you're trying to earn the community's interest so you can present to them in our monthly meetings or at different collaboration area groups and say, I have this idea, I need more people to support it, I need to understand how it can benefit more people. And then in our last phase where you're sharing back to the community, if you want your project to be sustained, the seed funding isn't enough to do sustainability and maintenance. You need to get the word out, get it to the right audience. And if you use the community, they're going to amplify your message if they like what they see. So use the community. If you want to find tester, data or code reviewers, future collaborators, talk to people. Okay, how about you, Annie?
My biggest would be to integrate a learning objective into your project. That these are small grant funding proposals, and like Leslie said, these aren't the money that we provide, or at least in the ESIP lab, is not going to sustain a project. What we really want is for you to propose something that at the get-go, at the very beginning, that you'll have to learn something. If you already know how to do it and this is just adding a little module, then it's really not taking full advantage. And the people that integrate a learning objective, that within these 6-month projects, they understand this is not the funding that's going to solve my science problem, but if I can learn a valuable skill through this 6-month project, then it will translate into the potential to really make a lot of headway on the science project in a long run. And I just echo what Leslie said in terms of leaning on a community and the resources that are provided, sharing your project through ESIP collaboration areas or with the CDI, and you really leaning on the infrastructure that we provide to magnify both the results that you have gained through your project, your objectives, and your learning objectives that you set out with. So I would leave it at that.
Annie, can I bring up something that's come up in the chat?
Yeah, absolutely.
Okay, I think it's a great comment that sometimes people are scared to look weak by asking for help. How can we address that? I just said, that's totally understood. It's a great point. Annie and I and ESIP and CDI, we need to do our job building up the trust between community members so they feel more comfortable.
And I think it's a really normal sense. It's right now, if you go to a conference like this, you probably feel like everyone opened an AWS console and just knew how to be a cloud computing expert, or automatically you're like, oh, Jupyter Notebooks, that's easy breezy. I mean, that the way that we talk at conferences and a lot of times in a community makes it seem like that knowledge acquisition process was not fraught with a lot of challenges. And so I think just normalizing the asking of questions and understanding the processes that it takes to gain knowledge. Also, that it's okay to ask anonymously on things like Stack Overflow, or when you come to a funder and if a project said, I am having a really hard time with this part of things, that Leslie and I both, as who run the projects, know our communities really well and can find mentors in certain technical spaces. So I would be able to, for example, find someone that would be a friendly and reasonable face to help move things along. So mostly I would say that is a very reasonable and great question. And I do think, again, like the community aspect and being okay that there are a lot of places to feel like it's okay to be a little anonymous when you're asking questions, even though people on message boards can often be pithy and a little brutal to people on asking basic questions, but I would still go through. So should we keep going, Leslie, or is there any other good things in chat?
I think maybe we can briefly address this next question, one more question, and keep them coming. We'll answer them at the end if we have questions. But does the learning objective weight go both directions? Like, if you want to build community tutorials, is that another way to, is that what we're saying as well? And I will just start by saying, yes, learn in all directions. You, Annie?
Yeah, I would say learning in all directions. I mean, some people it's the technical stuff is where you don't need the help, but are we saying, I guess if the question is about engagement and how to engage a community or how to use those community resources, that we're saying that can also seem non-intuitive and that we should provide those tutorials. I don't know if I'm hitting.
I think it's like we're saying you should use the community, but you can also let the community use you.
Oh yeah, absolutely. Yeah, but you have to put yourself out there first. I think the community needs to know what you're developing. And so finding those pathways to let people know what you're working on is a great thing. Cool.
All right. Yeah, I think we can move on.
All right. So let's see. How are we doing on time, Leslie? I think we're doing pretty well, right on time. So keeping on with this idea of learning new skills, this next section of the session today we're calling our skill swap. So I'm going to invite the people that we asked to participate. So Kathy and Ag from the ESIP lab, and I think it was Tanya, and who was our fourth CDIer?
Theo.
Flefford, so
also with Tanya. Yep.
Oh, and Flefford. So if Kathy, I've seen you. I think you're on.
I'm here.
Yay. Okay. So if Ag and Kathy, Flefford, Tanya, and Theo could all have your cameras on, and everyone else turn your cameras off. And then what I'd like you to do is go to the top of your screen, and there's a little drop down that says, let's see, actually we don't need to do that. Everyone, let's see, you guys are all there. So we've got Theo, okay. Peter's camera is still on. Peter, do you want to turn your camera off? We're just going to have the panelists up here. Okay, awesome. All right, so a main goal of this session is to better understand the ways people gain technical know-how. And so thank you, panelists, for being here. So we'd like each of you, I'm going to ask you kind of a series of questions to go through about your projects, and everyone else is just going to listen and learn from you. So I'm just going to go kind of around my screen, and I'm going to start with Ag. So Ag, could you unmute yourself, please?
There we go.
All right.
Okay.
Hi there. So, first, could you just let everyone know your name, affiliation, and the name of your project and who your funder was, either CDI or ESIP Lab?
Hi, my name is Agbli Amiko. I'm in Boulder, Colorado at NCAR. This was an ESIP Labs project, and basically we designed 3D printed Explorer weather stations.
Hold on, time out. So I'm going to ask you the next question. So thank you for answering the first bit. So, you were doing the right thing. You were giving the name of your project. So my next question was, briefly, can you tell the broader science question or your broad goal that you were working towards for this project?
Oh, thanks. And yeah, the main question was, how can high quality surface observations be affordably improved in sort of data sparse regions? So we really wanted to focus on data deserts and how we can make these observations affordable.
All right, awesome. So the next question is, can you tell us about a specific technical barrier that you encountered along the way?
One of the main things we were looking at was there was a few barriers. One being we wanted it to be open source and low cost sort of commodity based sort of sensors. So we tested out a wide range of sensors, and when you're looking at these sort of little microcontrollers, figuring out which one is the best one, and the key being uncomplicated deployment. So our focus was, we didn't want to have a lot of soldering. So we came up, we found things like Grove connectors where you can connect sensors without actually soldering. And just those were some of our technical barriers. Me not being in the team that we're working with, not really being electrical engineers per se, that was a really big technical barrier. So a lot of our work was focused on how to simplify and uncomplicate deployment issues.
Great. So you touched a little bit on this, but I wonder maybe you could expand the how you acquired that knowledge. So it sounds like you said you wanted to be uncomplicated, but can you take us through your process of you got to that, you started realizing that? What was that process like of figuring out what those technical barriers were and how you acquire the knowledge to overcome it?
So we had previous deployments of other versions of the 3D printed weather stations that required a whole lot of soldering, a whole lot of just overhead in terms of deployment. So it really came out of the need for a headache of those previous deployments to say, okay, there's a lot of things that we need to learn in terms of electronics and how sensitive microcontrollers work, but also there's got to be solutions that basically bypasses a lot of that work. So going in, looking at Thingiverse and different GitHub things, looking at what are the other resources that we can tap and microcontrollers that we can use, and things like Grove connectors. There was also something called quick connectors. So we tested a bunch of different connectors and figured out what's what things will work. We also tested things like communication protocols, started using one called MQTT, which is a nice little protocol that allows you to push data. And so communicate your data from your sensors. And so, yeah, it was just really testing and, just seeing what's out there, collaborating and talking to people within the ESIP community who had lots of different ideas about different things we should be looking at, and just trying to figure out how to reconfigure what was a really complicated deployment to figuring out how do we take out as many of those complications as we can.
Great. Thanks, Ag. I think that's since you're building hardware, it seems like that trial and error solution bit of learning was really critical, that's really cool to hear that process. And so note, you could see Ag's slide is up here, and I don't think you have, maybe we'll add the URL to the website.
Yeah,
and just, that would be awesome. And you could put it in chat, and just so everyone knows, so this weather station, it's really exciting. There's a lot of excitement happening. It is currently being deployed in Puerto Rico. There's some pretty significant data deserts on that island. And it's important because hurricanes go through and they don't have weather stations. And so Ag is working with the university down there. And so as part of this ESIP project, these 3D printed weather stations are being deployed down there. So hopefully we'll be able to share more of that information soon. So thanks so much, Ag. And the next project we're going to go around is to Tanya and Ford. So, all right. So Tanya, if you could unmute. Great. So Tanya, could you just tell everyone your name, affiliation, the name of your project, and funder?
Sure. So I'm Tanya Williamson. I'm with the Ohio, Kentucky, Indiana Water Science Center, and I'm with USGS. And the goal of our project is to use machine learning to look at a time series of satellite images to understand how tile drainage, which is a subsurface agricultural drainage strategy, how tile drainage has changed through time.
All right, great, thank you. And you're a CDI project.
It is a CDI, yeah.
And you touched on this a little bit in your first question, but I wonder if you can expand briefly on the broader science question of what tile drainage, what this project is trying to solve or understand.
Sure. So tile drains are privately managed, which means there's no large geographic database. Some states do keep track of them, but these are a subsurface feature. So obviously you can't see them by walking around. And over time, the technology has changed, as has the return on investment for putting new tile drainage in. And this affects water quality because nutrients and sediment can get straight into basically the stream system by going through here. It affects water budget because by moving water quickly out of the soil, it doesn't recharge into the groundwater system as well. And so you don't have the base flows essentially are thought to change. Over time, this has changed so that there's some evidence that it's also affecting the potential for flooding in areas because we're not using the ground to store the water. Instead, we're moving it so quickly out into the system. So there's also this goal within our organization we know right now to really look at predictive abilities of hydrologic models, but this is a part of our hydrologic system, which has been changing over time that we really haven't been able to inform. We generally have to infer it indirectly. And so we think we now have an opportunity to get a better understanding of it. And it expands across the country and across the world.
Great, that's super interesting, thank you. So Ford, I'm gonna switch over to you to ask about the technical bit of this. So can you explain or tell us about a technical barrier that you encountered along the way working with this project?
Yeah, sure. So the main task I was given was, given a satellite image, can you find these branch structures, these tile drainages? And just from the get-go, I have very little experience in terms of computer vision or anything like that. So I just thought, hearing that from Tanya, I'm like, all right, cool. I've got lots to learn. And so one of the main challenges I did encounter was the lots of potential noise sources and the sort of lack of the amount of data that we have. So it's not necessarily, Tanya's not giving me enough data. It's more of the nature of the project. So a common gut result answer would be, oh, just throw machine learning at it. But there's actually a lot behind that answer. And looking through it, the main solution is you can solve anything with enough computational power and data. So I can figure out the computational power part, but the data is the tricky thing. And so to fix that hurdle, or a way that I countered that is by basically going back to the basics, going back to computer science, a time before the hype with neural networks and machine learning basically came to fruition. And so that basically involves me reading through a whole bunch of computer vision algorithms and seeing what method really works for what we're doing. And if they don't work, why don't they work? And is there some way that we can tweak them just a bit so that they can do what we want them to do? So, yeah.
Great. So you started to hit on that solution bit of it. So I wonder if you could touch a bit more. So on your slide, you say NumPy and OpenCV are part of that. So I wonder if you could just keep going with that thought process from what you just said and kind of say, so you said a lot of reading. So back to, I have a vision of someone sitting cross-legged in the stacks of a library, reading computer science textbooks. Yep. But can you tell us about that knowledge acquisition part and then what the solution, speak a little bit more to that solution space?
Solution space. So how to solve that? I guess we can, how do I phrase that? If we want a solution, we first need to know the question. So the problem was, I know what I wanted. I wanted some algorithm that can make these tile drainages pop out and ignore everything else. And so I didn't know how to do that. I just know what I wanted. So first thing I did was just go through as many sources as I can. And I'll talk a little bit more about that later, but basically read as much about what just exists out there. And so the solutions mentioned, the NumPy and OpenCV, they're more like tools, but the challenge really was more conceptual of like, what algorithm would I need to do what I want to do? And then how would I implement that algorithm? And so you learn, okay, OpenCV's got mostly what I want. NumPy is great for, manipulating matrices, and that's what I'll be doing. So they're more like tools, but the challenge I had was just, I had no idea what I'm doing. Let me just start from there. And so the way I solve that is just reading through a bunch of blogs, reading through YouTube. So I mentioned some of my favorite channels, Computer File, but basically just exposing yourself to a huge range of solutions. And another common thing is, rather than looking for a solution specific for your question, like, okay, I need something that does this, let me find a specific solution. Instead, just look at any possible solution, any variety of techniques, expose yourself to them, understand each of them, and then later you'll realize like, oh, I actually learned about that back in a few weeks ago. Let me start to implement that. So you basically cast a wider net by learning way more than what you probably need for the project. And the advantages on top of that is a lot of the algorithms that I've learned are interconnected to each other, and they share lots of common principles. And so when you learn to understand one concept, one algorithm down to its core, you can learn a similar algorithm, and then you start to realize, well, oh, this algorithm is just this algorithm, but a little tweak to handle that. So you start to realize the connections between all of these algorithms. And then sooner or later, you start to realize, well, I could just write my own. I understand the fundamental concepts, might as well, make something unique for that purpose. So great. I guess the main thing I've learned is just cast a wide net. And that means just read and expose yourself to as much information as possible. Because in the end, you never know what solution you'll actually need, to solve your problem. So yeah.
Great. Well, thanks so much. That's a good juxtaposition to Ag's like hardware trial and error sensors, what's going to work. And kind of this one is the read and watch, and that I think it speaks to the different types of problems that you were both solving. So those are good examples. So next I'm going to move over to Kathy. And if we could go to soil data, yeah, great. So same deal. You've heard two of these now, Kathy. So could you tell your, again, your name, affiliation, your project, the name of your project, and funder?
I'm Kathy Todd Brown. I'm at the University of Florida. I'm a new professor down here. The project that we proposed was soil data models, sort of a review and an assessment of what the current soil data products were that were out there. I'm a computational biogeochemist, sort of by research. So I make computer models of how dirt breathes, and I'm interested in data to support my model development. So I've got some experience myself trying to harmonize data, and I have a lot of colleagues who do these purpose-built data harmonizations. And they typically are domain scientists who end up reinventing a lot of the informatics tools. So I wanted to do an assessment of how people are doing these data aggregation studies. What types of data models are they using? Are there any standardized vocabularies that we can start leveraging? And just sort of take a snapshot of where my field was in terms of these data aggregation studies.
Great, thanks. You spoke a little bit about the broader science question, which is my next question you're trying to solve, is getting a handle. You kind of just hit that in terms of where your community was at. So maybe I'll just go to the technical bit. So can you tell us, so in your slide, you go into you talk about surveys and these discussions. Can you maybe talk about a specific roadblock, like a technical roadblock that you hit related to your project, and then we'll just talk about the technical roadblock first.
So there's this very basic quantification of, it's a density measurement, it's a bulk density measurement in soils that is really fundamental to extrapolating any carbon stock estimates for a given location. And there are sort of 4 different standard ways to take this bulk density characterization, depending on whether or not you remove certain coarse fractions, or how will you dry the soil, sort of what the moisture state of the soil is, and they're not intercomparable. So when you're compiling these data products, you have to you have to use your domain knowledge of soil science in order to assign the measurement that was taken for that particular study to the correct slot, as it were, or column in the data table. So that's something that it sounds silly, but when you start piling on a dozen or so of these types of quantifications and these types of measurements, you start needing a background in soil science in order to fill out these data templates if you're trying to recover data from a manuscript or a study. And if you're trying to harmonize that. So oftentimes it's difficult to find people who are both comfortable automating data aggregation and data manipulation with something like an R script or a Python script, and have the soils background needed to correctly interpret the data that they're trying to knit together. So that was a really common pain point across all of the studies that we were talking to, and we did a direct one-on-one surveys with 7 different groups who've created.
So I'm going to do a quick timeout. So with how you got there, so this kind of is seeming like, so this is, you were coming up against that at that end, this kind of aggregation point. And so it sounds like now you're speaking to the bit more about what was your solution to that? And then how did you get there?
Yeah, so most of this project is about characterizing sort of how are people doing these studies. So what are some common hurdles that these groups are having around this data aggregation, and sort of trying to identify kind of these quasi-standard workflows that all of these groups are arriving at. And then sort of from what I'm hoping to do for the next phase of this is bring in some of the informatics from ESIP, things like, what's an ontology? How can that help you with these data aggregation projects and data harmonizations? And how can we coalesce a sort of a soil science group to go about developing these vocabularies and continuing to refresh and rework these ontologies as is needed. So soil science is particularly, you have to dig a hole and you have to grab a sample. And so it's a very labor intensive measurement to make generally. And so when you combine that with the fact that soils are very heterogeneous, these data points from lots of different studies start becoming more and more important. So you have this massive harmonization problem. Once you move away from something like we're a national survey lab, and that's our task, is we've got this standardized protocol and we always do things in the same way. And all of this I'm sorry, I'm looking at the chat and I'm getting distracted.
That's okay.
So soils, I think, are really unique use case where we can leverage the research, the data that's been gathered by the research community in these broader, to address these broader climate change questions.
Great.
So this was an ESIP labs. And so this project was a lot of, let's bring soil scientists to the table and maybe get some input from some of the informaticians and try to scope out what's currently being done in the field and how we could possibly make that easier.
Great. Thanks, Kathy. I think this is again, we've had trial and error, reading, use the community, and really that you're bringing a community solution to an ultimately informatics or community plus informatics type of problem. So thank you so much. And again, if you could see Kathy, I think she did have a virtual poster, which is still up in the research showcase. And thanks for putting your GitHub link on the top there. So we're gonna move to our next to our last skill swapper, Theo. So Theo, could you unmute and just, again, name, affiliation, name of your project, and funder.
Yeah, so hi, I'm Theo Barnhart. I'm at the USGS Wyoming-Montana Water Science Center up in Helena, Montana. And my project, which is a little different than the slide title, is to make a pilot data set of basin characteristics that are pre-computed for the continental or contiguous United States.
All right, and so this is a CDI funded project. So could you tell us the broad science question of why having this pre-characteristic or pre-basin characteristics solution would be important? Or
yeah,
the question you're trying to solve, maybe I should say it like that.
Yeah, no worries. So the USGS does a lot of kind of stream flow statistics, where we, get a bunch of characteristics of a watershed and use those to predict, say what the 100-year flood is, or what the low flow volume is, or something like that. And those are done usually with some kind of linear regression. But as our computational resources grow, we can start to kind of move that into potentially machine learning or pre-solving those traditional regression equations for the entire, the entire nation at some point. And to do that, we need the kind of the input data sets, these characteristics of the watersheds for every grid cell in the country. And my project was really just to kind of prototype and demonstrate that it is possible to compute these, kind of using this flow conditioned approach for the nation. But one of the major hurdles with this is, if you're going to, pre-compute everything, you have to store it somewhere. And that's kind of where this little roadblock came up, which is, how do we store these and make them usable?
All right, so yeah, that was the next question. So can you tell us a bit more about what was the specific technical barrier? Would you say it was just the storage side of things?
there can be barriers on, the amount of computational resources you have. We have, some supercomputers that can kind of churn out these data sets very quickly. But then, having people download entire grids where they really just need to query a single point isn't very efficient. And so that's where this kind of need for a good storage format came up. And we've tried a few different things. We've built NetCDFs out of these, but having to stand up some kind of OpenDAP server to handle point queries of the NetCDF files is a little tricky. Then we have to pay for a server. Being able to put metadata in the NetCDF file is nice, but maybe not worth the trouble. So then we kind of landed on these cloud optimized GeoTIFFs, which the first session I went to at ESIP was actually, it seemed like cogs were the, every other word. So it seems like people are using them, which is great. But we wanted something that was really easy to make, making a CF compliant NetCDF file, which allows it to be, used in GIS and things like that is a little tricky. GeoTIFFs are widely used, so they're very easy for people to pick up and run with. We wanted great compression in the data, because if we're going to throw up, 2 terabytes of data, we don't want to do that and needlessly use up bandwidth. And then we also wanted this kind of standalone file where we could, hit it with queries and not have to pay for a server.
So Theo, based on your slide, it looks like, worked through examples using Jupyter Science-Based S3 bucket. So would you categorize the how you got there? Sounds like you heard a lot of this was going on, but ultimately, were you doing examples in S3 and just saying, this is the fastest way to do things? Can you speak a little bit more about the, so we've heard the cog as your solution, but then how you got there, specifically how you made that decision?
Yeah, so it was kind of a mix of trial and error, trying different formats, and then, also kind of reading about how we make, a well-built cloud optimized GeoTIFF. There's some, questions about which compression methods you use and how do you tile it and things like that. And so we really just trial and errored that a little bit, and found a friend with an S3 bucket and uploaded a bunch of test, cloud optimized GeoTIFFs. And then, I kind of built a little query using raster IO in Python just to try to make sure that we were getting the same values back and to kind of time it. And I purposely didn't put kind of exactly what we used here, because your mileage will vary depending on your data set. So it's kind of best to do that kind of trial and error a little bit. But, using a lot of pre-built tools, mainly, the GDAL command line and then the Python raster IO package, we found it was really easy to build these. We just kind of followed some examples and then kind of crosswalked what we saw in the example for GDAL into our raster IO kind of parameters, and built it right into our workflow, so that we have these kind of coming out of our HPC natively as cloud optimized GeoTIFFs.
Great. Well, thanks so much, Theo. It sounds like, again, so that harkens back to Ag's talk of rather than a hardware trial and error, that this was a software trial and error, and you just kind of need to build things and test things out. And I like your found a friend with an S3 bucket, as if they're a rare commodity out there. But I do know feds have some walls to just spinning up an S3 bucket if you're at USGS. So I certainly understand that. So I will just say thank you to Ag, Kathy, Ford, Tanya, and Theo for keeping their cameras on. This was really great. And again, I'd encourage everyone to add questions to the chat if you have further questions for our presenters. So yeah, thanks everyone. And anyone else that would like to continue to have their cameras on are welcome to do that. But I will turn it over to Leslie for our last 10 minutes in the session.
All right, everyone. I just typed in the chat that my internet connection is acting weird. So let's hope it holds up for 10 more minutes. Thank you to the others who have contributed some slides. This link to the slides is in our agenda, and there are a number of other contributions. Thank you so much to those who put them in. I am planning to reuse those for another meeting, so you will be hearing from me, but thanks again to all of the participants for sharing. Okay, so now we are doing our closing circle. We have time to think about what just happened to us in the past 90 minutes. We were thrown here in the same Zoom. You were told that you are going to talk to each other. We're going to build community around developing technical expertise. We told you about 2 innovation seed funding opportunities, and we shared some of our paths to gaining technical expertise. So what we're going to do for this last part here is just to think what are some takeaways or interesting things that we heard today. And there is a space to share them in the meeting doc. I'll move over to sharing that in just a bit. And while we're going to do this, so this is called like silent reflection. It's a little bit weird, but I would like to ask you, if you're comfortable, turn your camera back on and go to the doc and type in that last part, what is a takeaway you have from today? We're going to give, 3-4 minutes, see if we see people still typing, we'll give you a little bit more time, but type something and then look at other people's takeaways and add a little +1 or an asterisk if you like what you saw there. And in that way, we'll have a nice record of things that we heard. I mean, for example, one thing that I heard that I'm going to remember is that read everything you can get your hands on. And, we said in the beginning of the session, if time were not an issue, right? Like, who has time to read? Well, maybe I need to schedule some time to actually do that reading. So that's one of my takeaways. Annie, what are you thinking?
Some of my takeaways are, just Theo's comment of the find a friend with an S3 bucket, that I think about how ESIP is a neutral organization that supports and has a lot of members from federal agencies, how we can help people do that kind of experimentation in the cloud more easily. I really was struck with, the juxtaposition of the trial by error kind of, which is very, I think we can all think of in a hardware space of seeing what will work and moving that into what that looks like in a software space, to I just echo what you said, Leslie, the taking time to learn and what that would look like. And I guess I would transfer these to when I was explaining ESIP, our kind of triangle of getting people past that productivity trap, and how hard it would be for some people to say, instead of writing code, I am going to read, and especially once you're out of graduate school. And if you're at a consulting company, you might have billable hours if you have another job. So I think those are a couple of my takeaways. And now I just want to read what other people are writing over here.
It might be weird. Don't leave. Just want to take about 3 minutes, let people write something, read the rest of them, and put a +1 or a star, and then we'll close it up after that. Okay, I'm going to mute myself.
Annie, did I miss something? Am I supposed to be somewhere? This is Rick.
We are just finishing up the, Rick, I don't know if that was meant for us or for off the camera, but we are just finishing up here. And I was just writing to Annie, hey, maybe it's time to start talking again. I know the silence thing is hard, but it really helps to get a lot of ideas down. So thank you, everyone. Let me just highlight a few that have a lot of these pluses here. So one I saw here, don't be afraid to try and fail. You know, we all need to learn from each other. So there's going to be successes and failures, and you can always frame it as a lesson learned. Okay, there's another one that we all need time to read, make the time, and iteratively, yes, how many times do you read something once and you're like, I don't get that yet. So read and ask new questions and read more. Let's see if there's another one. Okay, up towards the top, the payment when someone helps you is to pay it forward to someone else who needs help. That is a good one, and I hope there are lots of opportunities to do that, that ESIP and CDI help you be able to do that. And then, look, I see a highlight here. Okay, so recognizing that many people are reinventing the wheel is a good place to start with looking for how to improve the process or the workflow for others. So yes, we may strive to do less reinventing of the wheel, but just recognize it's kind of a fact of life. So how can we work on that and improve that? All right, great. I love all of the ideas here. These Google Docs are going to be here, Annie, right? So you can, you know, down, if you ever need more ideas, you just need an idea generator. This document is here. And then from my side, I just want to say thank you so much for a great, fun session for me. I really thank everyone for their time. Over to you, Annie, for any last words.
Yes, thanks everyone for your participation and attention. And I would also say, both for Leslie and I, that we are always interested in how our programs can better support our communities. So if you do have additional thoughts that you didn't share today about how either the ESIP Lab or CDI can better support you in your science, including helping you make community connections, we do understand that we say that lightly, but that often feels really daunting to individuals. Reaching out, being in a forum, introducing yourself on Slack, that we understand that that also can be a science challenge and one that we recognize. So again, I encourage you to reach out, and again, just thank you for your participation today. And we will see you all soon. Have a great afternoon.
Bye, everyone.
Bye, everyone. Thank you.
Thank you.